When trying to determine whether or not an inverse function exists, the easiest method is the horizontal line test. In effect, if a horizontal line touches the graph of a function more than once, there is no inverse. The question still remains though, how do we find the inverse? First, check using the horizontal line test that an inverse actually exists. Then replace f of x with x and x with y, and finally we will solve for y. This process is best explained by example, so we'll take a look at a couple here. First, we will find the inverse function of f of x is equal to 12 minus 3x over 5. To begin with, we replace the f of x with x, and we replace the original x with y. We begin the process to solve for y by first multiplying both sides by 5, then subtracting 12 from both sides, and then dividing both sides by negative 3. Finally, we replace the y with the f inverse notation. Also, notice that I did rewrite the fraction so that we did not have a negative 3 in the denominator. Here you can see the original function f of x and the inverse function side by side. Consider the function f of x is equal to x to the 7th minus 15. To find the inverse, we first replace f of x with x and x with y. To solve for y, I begin by adding 15 to both sides. I then take the 7th root of both sides of the equation. Once again, we rewrite the equation as f inverse of x is equal to the 7th root of x plus 15. We can once again see the original function side by side with its inverse function. Notice the similarities and differences between the two. In our final example, we'll look at the function f of x is equal to the square root of 5x minus 3. As before, we begin by replacing the f of x with x and the original x's with y. In order to solve for y, we first square both sides to remove the square root. I then add 3 to both sides and divide both sides by 5. By rewriting this with the f inverse notation, we have the inverse function is x squared plus 3 over 5. However, there is one small catch to this problem. In this example, we must restrict the domain. Take a moment and think, why? Why do we have to restrict the domain of this particular function? Consider this. The original function was the square root function. What is the domain and what is the range of that original function? This is what's going to tell us how we need to limit the domain of the inverse function. Let's take a look at a picture of these two graphs side by side. The important feature here is that the original function has a range of greater than 0. The fact that the range of the original function is greater than or equal to 0 means that the domain of the inverse function must also be greater than or equal to 0. Notice that this takes what would have been a parabola and actually cuts it in half.